It's November the 2nd. Another late night. Alright, let's get to it. I'm tired. Longest palindrome by concatenating two-letter words. You're given an array of strings. Each element of words consists of two lowercase English letters. Create the longest possible palindrome by selecting some elements from words and concatenating them in any order. Each element can be selected most once. Return the length of the longest palindrome you can create. If it's not possible, return 0. Palindrome, yeah, we know what a palindrome is. So the first one is 6. Second one, so everything is 2. 2, 2, 2, 2. So that makes it's only possible to be even, right? Everyone is 2, so only thing is even. Which means if we find AB, which means the one that are the same has to be staying in the center, right? If you have GG, well, GG can definitely be in the center. And if you find another GG, then that won't be here, right? So we can counter them. So all the one that's repeated can be in the center, right? Well, depending on repeated, how many times do we repeat? Even number of repeat. If we got odd number, it's actually odd number of repeat that works as well. Right? If I have GG, 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 that's also, right? Which means no matter how, we can always put them together, like towards the center. And what if we have AA? Ooh, that is not going to work. So if GG by itself, it works. But if we have two of them, GG and AA, that never works. And then we have double. But if we have GG, GG, and AA, that also works. So I think what happens is we need to have a pair, right? We need to have even pairs. If we have even pairs, right? So the same thing, and we have even pairs, then the even pairs all will work. But in the center, we can only have one odd, like just the repeats. We can only have one repeat to be placed in the center. All right, that's it. This is the only possibility for things to place in the center. There's only one. Yeah. So we can get through them, right? And then we can find, but actually what we can find is, we counter them first, right? And then for each one, if these two are the same, then we count how many they are, right? If it's even number, that's perfect. We can always put them, if it's even number, that's good. If it's odd number, then that's also good. But if it's odd number, then we used it already. So we cannot use another odd number. So we can only take even, right? We can only take one odd. And then we have anyone else C, then we just find if it has a CL. How many is that? How many is that? And then, because the palindrome, they have to be equal, right? So any additional pairs, like LC is not going to work because you cannot put it anywhere. But if you have LC and CL, right, that's a palindrome. So I think I have a clue, but not 100% sure. It's always like this. You have a clue, but you're not 100% sure. But it's fine. We can try. All right, we need a counter. Oh, I just realized something. I need to do this. Oh, I need to move this setup to my other laptop. Damn. Oh man. Yep, I have to. Yeah, it's unfortunate, but there's no other way. I don't see another way around. I have to do it in the other. I'm not bringing 2 laptops, right? I'm not bringing 2 laptops to campus. It's a long travel. One is more than enough. So I'll have to move this whole setup to the other. Well, the good thing is the setup is very easy, right? It's only just one software. So I just installed one software and then we are good to go on the other one. Yeah, but for somehow I like doing it here, even though this is a slower laptop. Alright, anyway, so we will do the words, right? And the rest equals 0. Okay. Then for W and count in counter dot items. Okay. Then we say if W0 is equal to W1, right? Then we say has single has single has center occupied. False, right? Then we say if C is a even number, then rest plus equal to C times 2. Else, right, if this or not, oh no, I have to go this, yeah, else, right, we say if not has center occupied, center has not occupied, then rest plus equal to C times 2. Again, so we can occupy the center, and then has center occupied equals true. Else rest plus equal to C minus 1 times 2. Because we cannot use, we have 3 pairs, we can only use 2 of them. We cannot use the other one because it's not right. Center has already been occupied. Cannot be occupied by another one. Else, so I can just add myself. I just realized that, right? Else, then we say, yeah, just add myself. So when we hit the other one, we'll add that one as well. The minimum, right? So we say rest shall plus equal to minimum C and counter W1 plus W0, which can be simplified as W, right? So we counter this, because it could be 0. So you get minimum of this times 2. And then we'll return rest. Okay. This 6. This 8. This 2. What the heck? Okay. Words. Yeah, I also have to sell my bike. Yeah, that's also something to worry about. Maybe during the time I have a lot of time to spend on the airport. Something I can think about. What else? 10. Print. Hold on. I actually don't know. It's import string. String dot ASCII letter lowercase. Yes. So it's from random put choice. For this in range 10, print. For this in range, do 10 first, and then we say choice string dot ASCII lowercase. Oh, plus the two of them. There we go. It works. Maybe it has to be. Yep, it doesn't work. This looks horrendous. And no, I don't think this one works. You know what? Redo this, and then, man, I hate this. But there's no other way. I have to do this. And then I absolutely did not like it. So little. I need more. 1,000. Hopefully we can go to the end. Come on, yes. 1,000 is good. Ooh. Damn, it's slow. Struggling. Gotta be kidding me, man. Alright, I'm not using this method. Dude. Nope. It ain't even right. Ah, screw this, man. Yeah, because you try to edit at the same time, so that's why it doesn't work. All right, don't waste this. I think maybe just one of them. Yeah, one of them has a missed. The other one looks good. All right, how you go? Invalid test case. Jesus. Okay. All right, we'll try it again. All right, so we're gonna use this. Oh, is this? No, this? Yes. Placed by this. Place all. Well, doesn't take too long. Okay. Wow, I've done it before. 2022 in January. Oh. Two, 1, 3. Oh, this is a contest, right? Yeah, I think this is a contest. Yeah, whatever. Find for each word that has the same letter repeated. We can always form palindrome if the count is even, or we can allow only one odd count, which will be placed in the center. For each word that does not have any letter repeated, right, then simply find its reverse and take the smaller count between the two. Yep. Oh wow. Put into an array. Yeah. This is 9 months ago. Oh. Pair unpair. That's very nice. Is this one faster? 120. 120 is the same. Huh. This is slower. Okay, let's try this pair and unpair. Seems interesting. From the submission. On this day. So we do a counter, but we don't counter each thing. Alright, rest is 0. Then for wording words, reverse word is word reversed. Then we say if counter reverse word, right? Then they can form. So say rest plus equal 4. Right. Then because we use it, so we need to remove it. So say counter reverse word minus equal 1. Right. Then we want to know if there are any unpaired. Oh, basically just check if they're the same. Hold on, let me think. So I encounter a new one. Then I do this, so I reduce it and then we compare. Then we will have unpaired. Right? We'll have unpaired. Then we say if W is equal to reverse W. Unpaired shall no, it's count. Hey, hold on. Unpaired, this is handle the last two. If we have unpaired, what do you mean by unpaired? I would just say, because every time we get a new word, and then we just pair them, right? And then we remove that word. So we have that. And if this one comes in, and then they check, then we pair it. And we don't check, we put it in there, right? Then that's an unpaired. Now we have there's another one, then we will remove it. Alright, if you think about it, we have this, and the next time come in, and then they are the same, then we'll remove it. Then we should say if W is equal to reverse W and counter W, then we say we have unpaired plus equal 1. No, because I remove it. Then we say and not. That should be minus equal 1. else counter w plus equal 1. Right? If w is equal to ref w, then impaired plus equal 1. So we go this, then we can return res plus 2 if unpaired palindrome is larger than 0, else is 0. Something like that. It's the same. Okay, that's it. You wanna take a look? Yeah, I can take a look, but I don't have any gun to do this. What's this? Palindrome again. Given a S containing lowercase letters and integer k. Change some characters of S to other lowercase letter. Divide S into k non-empty disjoint substrings such that each substring is a palindrome. Minimum number of characters you need to change to divide a string. What does it mean by disjoint substring? Okay, I think I know what this joint substring is. It just has to be one next to the other. That's what it means. Yeah, so divide into 2, and then we need to change. So we need to divide into k, then empty disjoint. And each of them has to be a palindrome. So if it's 2, I mean, the only thing we can do is, yeah, k is 2, which means we take 1 cut. Right? It's 3, we take 2 cuts. 8, we take 7 cuts. There's only 2, 3, 4, 5, 6, 7, only 7 cuts. 3 would take 2 cuts, right? Then we can take here, we can take here, we can take any cuts. And then once we take the cut, then we need to change. And we need to know the minimum number of characters you need to change to divide a string. Most likely it's a DP. I think the best example is AABBCC. How would you do that? So the cuts can be made here, 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 right? So I can make 2 cuts. So I can say that could be any, if I know, given any index from certain index to another index, what's the minimum number of change we need, right? That's a problem. And once we solve that problem, then I know the minimum needed change for any single. So then what we can do is, do we just brute force it? Because it's only 100, right? Maybe we can brute force it. Because it's disjoint, right? It's disjoint, which means we have the position to cut. So we can cut here, and I can cut here, here, here. Oh, we cut here, we can cut here, here, cut here, cut here, right? But if we have a lot, Then we set all of this in this way and cut one. And then, it's alright, can do this with a smaller number of cuts. But eventually, the number is just C 100 was actually 100. C length, right? C length minus 1. Choose whatever it is. How big can this value go though? Seriously, how big can this value go? We're talking about 100, let's go 99, because that's the maximum number of cuts. Choose, usually it's half, so what, 50? Damn, that's a lot. Cannot do that. Need to be smarter. It has to also be consecutive. So we know if we do 1, that's definitely a good choice. And if we have palindrome already, we shall cut them out, right? If we cut the palindrome out, then, yeah, let's say we cut the palindrome, we find the longest palindrome. Find the longest palindrome, that's an interesting problem. If we find the longest palindrome, right, and then the remaining, because if we have a palindrome, we can do whatever we want. Yeah, honestly, we cannot do whatever we want, because if I have a large palindrome and then I don't have enough, right? Let's say ABC, let's say we have A, B, C, C, B, A, and D and E. So if we cut into 1, 2, 3, that's good, but if we want to cut into 4, then we have a problem. Alright, if we want to cut into 4, I have to cut here. 2, 3, and then 4. So it will be 1. Is that 1? Yeah, it's 1. But no, that's not the way to go. But we cannot like brute force it. We cannot. If I have already an optimal split for the previous string, right? If I have already the minimal number that we need to change for the previous, for k minus 1. Yeah, let's just say if we have AABB, right? We have AABB and then k equals 2. And then we already solved it. This one requires 0. And then for now, we want a new one come in. And that's 0 as well, because it's a new one, right? And if a new one come in, that's still 0. right? Everything new one coming will always be 0. So, but now what we say is, well, if we can get it done early, we can say given me from start to an end, right? And then given me k equals 1 equals 2 equals 3. Minimum of getting 1. I can calculate that, right? The minimum of getting 2, I can calculate getting 3, right? You cannot getting 3. Because if you get everything, then the new one, oh yeah, you can get all of them. So the new one just coming in will have to group with the previous one. Going, we say at this point, I say this is the optimal, right? And then we throw this to the remainder. We go. This is the optimal. And we throw these to the remainder. So I say, what do we have? We have index. So BBC, we say A, okay. And then what we want to find is A, B, B, C. What's the minimum for k equals 2? Take A, so now it's B, B, C for 1. So we do whatever calculation we need to do. So we find this one is 1, right? Change is 1, minimum is 1. So we have index, have k and I, 0, 1, 2, 0, 1, 2, 3, 4. Zero, 1, 2, 3, 4, right? K is can equal to 1, 2, 3. This is K, this is I. So when I equal to 0, when k equals 1, right? When k equals 1, everybody is 0. No, not right. This is from this one to the end. Right, this one to the end. So from 4 to the end. 0, 1, 2, 3, 4 to the end of 1, that's a 0. And then from 3 to the end, if it's 2, from 2, then that's not possible. Hold on, let's go step by step, right? So we take 0. So we want a 0, 3, right? We don't know what 0, 3 is. So we need to find out 1, 2. But we don't know what 1, 2 is. So we need to find out 0, 1. No, 2, 1, right? So now we want to find out 0, 1, 1, 2. 0, 1, 2. Yeah, you don't like this, right? It's okay. It's okay. So position 2, we have 1. Then this one, we change 1. So minimum change is 1. Then going back here, because this one is 0 change, so this changes 1. 0 changes 1. Okay? So now, oh, actually, I'm not done yet. Now we can say, okay, we can group these two together. Right? So we group these two together, so we have 3. 3, 1. 3, 1 is also 1. Right? So now coming here, AB is 1, right? AB is 1. So that give me 2, right? So it's bigger, so that's still gonna be 1. And then we do this. Now see, that's 0. ABB give me, ABB is what? It's ABB is 1. So that's also 1. So that's still 1. So yeah, so that's how everything is done. Right? And then coming back, it's A, putting here is 1. Right, so we have 1. Now we do AA. Okay, so we go 1, 2. 2, 2. So we want to know 2, 2. What's 2, 2? Yeah, 2, 2. Well, 2, 2. So I have BBC. We end up split into 2, so we're going to do this. So I have 3, 1. 3, 1, we've done it already. Because that's BC, right? We've done it already. 3, 1, we've done it already. So that's 1. B, so that's going to be 1. So 2, 2, now we have a 1. Or we can do, that's 0. That's 0. So that's actually 0. So 2, 2 is actually 0. So in this case, now we have a 0. And if we have a 0, we can actually stop. Right? Whenever we have a 0, we can stop. But we never know, so we keep going. Right? So we say we're going to do AAB. Right? AAB. And then BC. So we will take B, which is 3, 2. 2, 3, right? 2, 3. Connect to 2, we'll start with 3. And then we only have one choice, which is giving me 0. Right? And then AAB required change of 1. So that's also 1. So that's a 1. Right? And then that's it. That's all we can go. So the answer is going to be 0. So basically, we start from here, 2. Alright. 2, 1, 2, 2, 2, 3. Can now do 2, 4. 1. We never do 1, 1. Yeah, because this it's not possible 1, 1. So this looks promising, but let's try this tomorrow then. Yeah, we have this idea. I'm gonna try it tomorrow. I just don't want to do it today. So the added complexity is to find how many changes are needed. Yeah, that's gonna cost time too. I'm not sure. Feels like in a timeout, but we're gonna try. We're going to try. Alright, I'll see you guys tomorrow and try it tomorrow. Adios.